Okay, this is 2.1 rates of change and limits. This is part 3, last part of this section. Your objectives for this section are to apply one and two-sided limits and also to apply the sandwich theorem. So far, we've been talking about limits, but we've been talking about two-sided limits. Right now, we're going to talk about one-sided limits. So you can see these limits are a little bit different. They have a plus and a minus written up here as a superscript to that C. If you have a plus sign up here, that means we're talking about a right-hand limit, which approaches from the right. If you have a minus, that is a left-hand limit approaching from the left. Let me show you what that means. So right here we have a graph of a function. You could have any function here. And let's say I wanted to find the limit of this function, let's call it f of x, as x approaches 2. And let's do the right-handed limit first. Okay, so from the right. And right is over here, left is over here. Okay, so if we are traveling along this line from the right towards 2, this way, then we see that our limit is equal to 0. So the y value here is 0. But the important part is you are traveling along this graph from the right to the left. For the left-handed limit, you do the same thing, but come in from the left. So you're going to come in this way. Come down here and up here. And we arrive at 2. You see that this also equals 0. So on this graph, your right-hand limit and left-hand limit of f of x as x approaches 2 are the same for right and left-handed limits, but that will not always be the case. Okay, example 1. The greatest integer function f of x equals the greatest integer of x has different right and left-hand limits at each integer. And this is a graph of that function. So this is f of x is the greatest integer of x. Okay. So we want to find the limit of this function as x approaches 3 from the right. And if you need a way to remember right versus left-hand limit, which one stands for right, which one stands for left, as you look at the number line going towards the right, you're in the positive x's. Going towards the left, you're in the negative x's. So that's one way that you might remember that. Okay, so moving towards 3 from the right, coming down this way, it looks like, well, right here is 3. We get 3. So this equals 3. But if we're coming up this way from the left, so moving up, 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 we're going to approach here, and before we get to the 3, we hit a y equals 2. So here, the right-hand limit of this function as x approaches 3 is 3, and the left-hand limit as x approaches 3 is 2. So this is an example of when the right and left-hand limit are different, and that is due to this jump in the graph. Okay. One-sided and two-sided limits. A function f of x has a limit as x approaches c if and only if the right-hand and left-hand limits at c exist and are equal. So, and this is the technical language for you, the math language. If you look back at this graph here, you see that There is a right-hand limit as x approaches 3. There is a left-hand limit as x approaches 3, but they are not equal. So if you wanted to find just the limit as x approaches 3 for the greatest integer function of x, this does not exist. So the right and left-hand limits must be equal for there to be a limit at C. Okay, example 2. All of the following are true about this complicated piecewise function. So f of x equals all this. And before we get into the statements that are true, I think we should graph this function because it is a little bit easier to it's a little bit easier to see that these statements are true from the picture, from the graph. So coming down here, our first statement says f of x equals negative x plus 1 for values between 0 and 1. So that means that at 0, we're going to have negative 0 plus 1, which is 1. And at 1, although that would be an open circle at 1, we have negative 1 plus 1 is 0. So we have a little straight line from 0, 1 to 1, 0. So 0, 1, 1, 0. Okay, next part. F of x equals 1 between 1 and 2. So that is here. It's a closed circle and then an open circle on 2. Okay. F of x is 2 when x equals 2. So there's a point up here. Then we have between 2 and 3. So if we plug in a 2, we have 2 minus 1 is 1. Plug in a 3. So we have a point 2, 1. That's an open circle. And then there's already one there. 3, 2. Right here, closed circle. Okay. Okay. And our last statement, so between 3 and 4, so negative 3 plus 5 is 2, and negative 4 plus 5 is 1. So 3, 2 already taken care of, and 4, 1 is right here. Okay, so here is our graph. And let's look at the next page at the same time. Okay, so this says at x equals 0, the limit, the right-hand limit of f of x equals 1. And you can see that you can only have a right-hand limit because there's nothing on the left side. But as you approach from the right, your y value becomes 1. Okay. At x equals 1, so that's right here. The left-hand limit, that's the minus, is 0. That's true. It looks like we get pretty close to 0 right there. The right-hand limit, that's the plus sign, is equal to 1. That's up here. Okay. At x equals 2, the left-hand limit coming in from the left is equal to 1. And the right-hand limit coming down from the right is also equal to 1. So notice here that even though those two limits are equal, the function at x equals 2 is equal to 2. So the limit does not necessarily need to be equal to the value of the function at that point on the graph. Right, so right here, because the right and left hand limits are equal, the limit as x tends to 2 of f of x is equal to 1. Okay. At x equals 3, the left-hand limit of this function is equal to the right-hand limit of the function. You see them approaching the same point right here. They're both approaching 2. So the limit is equal. The right and left-hand limits are equal, meaning the limit at x equals 3 is 2. Okay. At x equals 4, we see that the left-hand limit is equal to 1. The left-hand limit of that function approaching 4 is 1. And this statement here says that non-integer values of c, so like 3.5, 2.93, anything like that. So non-integer values of c between 0 and 4, that's where this function is defined. F has a limit as x tends to c. So the limits are whatever y value appears on the graph.